All right, you are faced with this question in your chemistry examination. All right, now questions on this topic that has to do with calculating oxidation state is a question that JAM asks every year. And now you see this question, how do you attempt it? How do you attempt it? Now there are rules to calculating oxidation state, but then I'm just going to simplify it to the most basic things. All right, number one, you should understand the difference between a compound and a radical. Now, the difference between a compound and a radical. Now, how do you know radical? Radicals are a group of atoms that carry charge, all right, and they function as a single unit. For example, at least you have two, three atoms with charge, okay? So we have this. This is a radical because it has charge, made up of phosphorus and oxygen. This is a radical, contains charge. SO4 2 minus. This is a radical, it contains charge. OH minus. This is a radical, two atoms, all right, with charge. So once you just see two, three atoms grouped together carrying a charge, so that is what a radical. Now what's a compound? A compound is just atoms, right, without charge. Okay, I just made that definition because of what we are treating so that you really get it, but that's not the actual definition of a compound. All right, the actual definition of a compound is that a compound is the combination of two or more elements, right, chemically joined together. Okay, so compound, for the sake of this topic, I'll just treat it as compounds. You have two or more atoms without a charge. If you look at this guy, K2Cr2O7, we have potassium, we have chromium, we have oxygen. They do not have charge. So this is a compound. Now, that's the first rule you should follow. Okay, so we have this K2Cr2O7. Now, for a compound, now we have identified this as a compound. Now, there is a rule. For a compound, the algebraic sum will be equal to 0. Okay? For a compound, the algebraic sum will be equal to 0. And for a radical, the algebraic sum will be equal to the charge on the radical. If you look at this first guy now, the charge on the radical is what? 3 minus 3. So the algebraic sum will be equal to what? Minus 3. The charge on this radical is minus 1. So the algebraic sum will be minus 1. Charge on this radical is minus 2. The algebraic sum will be minus 2. Charge on this radical is minus 1, so you have minus 1. Charge on this radical is plus 1, so you have plus 1. Okay, but for a compound that does not have charge, okay, the sum of the atoms in the compound will be equated to 0. So you have 2K plus 2Cr plus 7 oxygen equal to what? 0. For a compound, please. For a compound, equate to 0. For a radical, equate to the charge on the radical. So now, the valency, which corresponds to the oxidation state, the valency of potassium is plus 1, lithium is plus 1, sodium is plus 1, potassium is plus 1 because they are found in what? Group 1. So it becomes 2 times 1 plus, remember I'm looking for CRO, right? So 2CRO plus 7 times. Now, on the rule, please take note, have this, all right? In most compounds, the oxidation state of oxygen is minus 2. In most compounds, the oxidation state of oxygen is minus 2, all right? Except in peroxides. What are peroxides? Things like hydrogen peroxide, H2O2, sodium peroxide, Na2O2. So with the exception of the peroxides, all right, in most compounds, the oxidation state of oxygen is minus 2. So oxidation state of oxygen minus 2 equals to 0. So 2 times 1 is 2 plus 2CrO plus 7 times minus 2. 7 times minus 2 is what? Minus 14. Equate it to 0. Please don't forget to always equate to 0. Now, 2 plus 2CrO. Now, plus times minus is what? Minus. Plus times minus equal to minus. minus times plus equal to minus, plus times plus equal to plus, and minus times minus equal to what? Plus. So this is just a mathematical rule. Okay, that's just a mathematical rule. So plus times minus is what? Minus 14 equal to 0. Alright, so we now have this 2 plus, now this my 2CR, and then you have minus 14. Minus 14 we have to cross over here. Alright, minus 14 we cross over this way, and we now have equal to, now when a number is crossing over an equal to sign, all right, the sign of that number changes. So if it's negative crossing to positive, to the other side of an equal to sign, it changes to positive. If it's positive crossing to the other side of an equal to sign, it changes to what? Negative. So minus 14 crosses over, it becomes what? Plus 14. Now plus 2 we cross over. So you now have 2CR is equal to plus 14. Remember this plus here. So crossing over an equal to sign, the plus changes to what? Minus. So plus 14 minus 2. Plus 14 minus 2 will give you 2CR is equal to what? Plus 12. Now, here's the big deal. Here's the big deal. The big deal is that we're asked to find the oxidation state of chromium, not 2 chromium. Alright? Oxidation state of chromium, not 2 chromium. So what we are going to do here is that we're going to divide both sides by 2 so that chromium can stand on its own. So 2CR divided by 2 equal to plus 12 divided by what? 2. So 2 cancel out 2. Therefore, CR is equal to plus 12 divided by 2. Plus 12 divided by 2. Just forget about the plus 12. 12 divided by 2. What are we going to get? We're going to get what? 6. So just add the plus. So it becomes what? Plus 6. So plus 6 becomes what? Our final answer, which is option B.